Welcome to part 4 of the Positron lab. We left off discussion in part 3, a discussion of the beamline that you can see before you here, and now our system has been heating for approximately 7 minutes, and now you can see the characteristic beautiful purple glow of the iodine gas. Let's take a closer look. Vessel, you will notice suspended the sodium iodide, the sodium 22 positron source. This, of course, as we reviewed in part 1, will combine with the iodine gas to form positronium in its para and ortho configurations. It will then travel down what is now the red line, or the beam line with the coils around it, into the flow chamber, and thence into the reaction chamber, where you can begin to see a slight purple tinge as the gas is coming into it. We are now going to turn on the water so as to preserve adiabatic conditions. Our temperature has now risen in the top of the reaction vessel to about 30 degrees Celsius, which is not inordinately hot, but we don't want to affect our experimental results over here in the reaction chamber by letting this go much above room temperature. So we will now turn on the water, and if you will notice, if you will watch, you will see that begin to flow through, exerting a cooling effect. Also notice turbulent flow. That's not going to affect the reaction vessel, but it may make it a little bit harder to visualize, at least at first. So we'll try to adjust that later if we're going to do any benchmarking in the chamber itself. But you can see the water as it flows through. We are also going to increase our airflow through the reaction chamber a little bit, and you'll notice the ball will move up out of sight. But that's all right. We will be using that just to that, and now you can begin to see a slight purple glow in the reaction chamber, telling us that indeed our iodine is making it into the chamber along with the positrons that have attached to it in the para and ortho configurations. We also have our coincidence counters, in which we will be doing graphing later, so you can pay attention to those as we go along. Now we're going to turn our attention to the reason we set up the experiment today, and that is to test our beam line. So in order to do that, let us now go over to our power supply, and we will start at low voltages and then work our way up. So I'm going to turn on, this is a basic Fredriksson Pasco unit made in Denmark. The maximum it has is 24 volts, but it can take us up to 6 amps, simply because we do have the in-current electricity from the municipal power supply. So let us now turn on the system and start moving our voltages through the current, through the ring. So now let us move our voltage up to approximately 5 volts AC, and then we will also now begin to introduce our direct current. And we'll strive for maybe 8 volts, because I'm watching our amperages there, so we're going to, we want quite a bit of amperage, because the magnetic capability of the beam line is a function of the amperage. And then you will see over here the system as it is going along. Also, as we go along, we will have more and more iodine vapor as the system heats. It's very slow to heat, given the fact that it is in a sand bath, but you will notice by the steam in the bottom of the reaction vessel that we are getting some melting of the 10 grams of iodine with which we began, so this is good. And then, again, as I say, you will begin to notice